Welcome to the first collaboration of 2020. I have wood by Wright in the shop. James Wright has driven up all the way from Illinois to Saskatoon, a 20-hour drive to bring me these two lathes. We are each going to restore one of them. You can check out his videos on his process. We had to do a lot more manufacturing for his lathe than for mine. He was kind enough to allow me to keep the more original and historically accurate parts of the two lathes, and he kind of took the parts that we ended up fabricating because he plans on using this lathe in his workshop, since he does not use power tools at all on his channel. So this would fit well with him, whereas I obviously use power tools, and I am probably not going to pedal my lathe consistently over time. So mine's more for just the show of it or to pass it along, which I really hope to do. His is more for actual usage. Anyways, what we have here are two Barnes number 5 lathes. Mine is a little bit older, probably early 19th century. We're talking 1900s, 1910s, and his might be in the 20s or 30s. So there isn't much difference between the two, but there's enough. They're both what would be considered now an 11-inch lathe. At least that's what the swing is. So that might give you a reference for the kind of size of these lathes here. We've taken just the main parts off the lathe. Here's the headstock. I've taken the tailstock and the cross slide off as well. And I'm just going to be working my way through each one of those as I try and discover how to actually take this thing apart. James is working just right behind me on the other workbench at the same time, essentially doing the same thing, and we're helping each other out when we finally figure out how some of these come apart, because the headstock here was a little confusing since it has unnecessarily massive bronze bearings. It just is not proportional at all, so having those in the way when you're trying to disassemble was getting confusing to us. We couldn't really figure it out, and you ended up having to just pry it off and tap the bearing out after some long deliverance. The condition of both lathes isn't too bad. I've definitely seen worse lathes that are 100 years old, so on that aspect it's nice. The bronze bearing surfaces are fantastic. When I was disassembling, I was checking for any slop or any movement. I really didn't notice anything, which is awesome, but maybe to be expected for something that's foot powered. We're not really getting a lot of forces, a lot of wear, a lot of use in general, most likely, from someone using this lathe. The cross slide here is a little unique in that where the tool post is held in place swivels on a bolt that's attached to the cross slide, which is all cast as one piece. Kind of odd in terms of today's lathe design standards, but at the time, these were very good lathes. They were well made and well machined. You can even see when I finally do spin this part out, you can see the planer marks and the nice scrapey marks that we all love to see come through, and that's nice. You know, not all lathes at the time were of the highest quality, just like today. Here's the bolt I'm talking about that allows you to swivel the tool post to create tapers or convex items. Once loose and not seized from rust, it swivels out. You can swivel it full 360 if you want. You just have to lock the nut back down. It doesn't necessarily help with the rigidity, but this was the choice that the manufacturer made in cross-slide design at the time. Later on, there were options to have a cross-slide where you can move, where it's compounded, where you can move it in and out and side to side. And that's the one that James actually ended up taking home. His is a little later, so he has that version of the cross-slide. It's definitely more useful for him, as he will be using this. This, once again, is just for funsies for me. The handles were all fairly good except for the first one I took off on the cross-slide. It had an end broken to it, and I'm just going to leave it how it is until I either find a replacement or think about making one. It's kind of not simple to machine spheres, so I gotta think about that a little bit. I don't have any wrenches. I've never used a wrench in my life. The tailstock was still running really smoothly, and you can kind of see that this whole thing was just painted over, fully assembled, which drives me nuts. It was given black paint where black paint shouldn't be, which was odd, but the underlying black is Japanning, so I'm not massively concerned about lead at this point. There might just be this fresh layer of paint that has lead. Either way, I gotta remove it before we sandblast. Anyways, the entire design in terms of the ways, and you can kind of see them here, it's dovetailed on, and that's how all these parts, the headstock and the tailstock and the steady rest and follow rest, they all have that design. But what doesn't fit on, like a dovetail, is the cross slide, and it just slides on a lower machine shelf than everything else, which is a very unusual design. Maybe at the time it was more common, but today you don't really see that at all. This is the part that either engages or disengages the other unique feature in this lathe, which is a twin lead screw design. So there are two threaded Acme rods, and they are turning in opposite directions, and you would move the nut up to engage with the top one or the lower one, and then it would change the position and direction of the carriage. This is the really neat chuck. It's a Little Giant chuck by Westcott, and I love this thing. I think this thing looks incredibly cool. I ended up keeping this chuck for myself and giving James the ability to use the 3-jaw chuck, since once again he'll actually be using the lathe on a more frequent basis than I would ever use it. So I'll just have to kind of make do with this, what is essentially a drill chuck on the lathe for now, for my turning demonstration purposes. It's also somewhat foreign to me personally to see a drill chuck that spins onto the actual spindle where the headstock is, and not the drill chuck that's usually in the tailstock as you would see today. It's kind of odd to have that feature. I'm not exactly sure what they were drilling, but you would have to have clamped it to the lathe and then drill and move the headstock and drill into stuff. It just seems very odd. So after everything was taken apart on both of our lathes, we basically maxed this bucket out. I finally put more than just a third of this bucket filled with evaporust, and we just let it soak as usual overnight, and it was fine and fantastic as always. I was a little concerned that the level of rusty stuff to actual liquid was too high and that we might have needed to go get more, but it ended up being okay in the end. So James also brought along a bunch of newly cast pieces. These were cast by the Catskill Foundry in the Catskills in New York State. And they were cast using the actual original Barnes wooden patterns, which is amazing. So that's incredibly cool, and he brought extras since one of the lathes was missing a bunch of parts. So we had to do a little bit of machining to get these to fit on their appropriate shafts. This is the drive gear where the chain drive would go from the pedals to the big flywheel. And this is the gear that would be on the big flywheel. So it's very rough in terms of a chain drive. It's not, you know, the most accurate, but it doesn't need to be. It's just power transferring at this point. We also bored this out to the specific diameter that's on the large flywheel on the lathe. This was neat because I haven't done a lot of this, and the boring head came with the Bridgeport mill that is not even a few months old, to me at least, so it's nice to get a chance to use this and learn all the ways of the boring head. They also needed to be tapped for a little set screw. At least this doesn't need to be as accurate as the boring head method, so I can just drill it out by hand. It's not the end of the world. These are cast iron. They're not ductile or cast steel, so I do need to be a little bit careful, but since they're cast, I don't need to use any lubrication on any of the cutting tools, including the tap right here. So I did that to the number of other pieces as well, but there's no point in showing duplicates of that. Here I'm moving that top paint layer and whatever of the Japanning wants to actually come off, since Japanning is very hit or miss in terms of coming off with the world's most poisonous paint stripper. So it's just the way it wants to be. It seems fine. I'm getting down to the bare steel in this case, so it's eating the Japanning this time. Sometimes the paint stripper just won't. It's the recipe of the Japanning. Here we are, both wire wheeling like crazy people. We spent a lot of time wire wheeling on drill presses. I haven't used my little tiny drill press as a wire wheel standing up in a long time. Although I did use it as a wire wheel to do the tub of the washing machine. So it's probably almost an entire day of just wire wheeling. He only had 3 days, so we really had to push this as quickly as we could, and we worked together as much as we can. And we got to the painting part before he had to leave, which is exactly what he wanted. He wanted to finish it at home with his own paint. So that worked out well. And we're hitting this and every other part on Earth with the etching primer, just to give it the greatest possible chance of a nice bond. Since these are steel parts, even though they're not aluminum where you would usually use the etcher, I like to use the etching primer basically all the time. The flywheels were also thrown in the evaporust after the first batch of stuff was thrown in, because there was just so much stuff it wouldn't fit. And these legs were not put in the evaporust. They were just wire wheeled, as you saw James doing earlier. And then we hit it with a rust converter, just to make sure all the little tiny spots of rust are gone.
Original Barnes number 5.
Oh my god. Orange?
What? Yeah.
Orange. Orange.
Orange is good.
Please leave immediately.
No.
Yeah! No! And stay out. So James blasphemed with his orange paint. I think he actually ended up painting it blue, and I'm not even joking. So if you want to go check that out, you can. He paints all of his antique tools blue, just so they're marked as his. It's this kind of metallic sparkly blue, so it's even more crazy, but you can do whatever you want with your lathe. So here we are, finally at the reassembly, which includes maximum applications of maple syrup to every possible surface to ensure the most free moving of parts on Earth. These all turned out great in the sense that all the parts after wire wheeling and evaporusting were not massively pitted or deformed in any way or damaged. It's just always a concern when you have so many parts and you just, you pick up a lathe and you're thinking, okay, 90% of it's good, but really, it's 40% of it is good and the rest is needs to be replaced or fixed or something. So it's just nice to see after wire wheeling what is actually an issue and what isn't. As you can see, it runs very smoothly, which makes me very happy because I'm going to be pedaling this, and any form of resistance that I encounter is not going to make the pedaling any easier. So this needs to be as smooth as possible. I did check off camera. I just didn't want to add it to the length of this video. It's already long enough, but basically I tried rocking the spindle back and forth to get any play out of it at all, and it was surprisingly solid, so I'm very happy to see that. This gear is what transfers a lot of that power, but it seems like the gap between the gear and this part that I'm threading on, the kind of nut, is too much. I don't know if something else went there. On James, the collar beside the knurled portion of that nut is much thicker, and it touches, and I'll actually engage and press into the gear to keep it in place. So I'm not really sure if I'm missing something there, or that was just the original design, since this is an older version of this lathe. I don't know. There is some information on this type of lathe, but not as much as I would like. A lot of questions that it really didn't get answered, but what can you do? The thing is, over 110 years old at least by now. So there are a lot of collectors that absolutely love any foot-powered machinery, pedal or treadle based. So it's probably a matter of me talking to somebody rather than just trying to find something online. I'm sure there's an expert that I can discuss the hilarious foot-powered lathes with. This is the back gear assembly. I'm just putting the handle on it. That'll allow me to slow down the spindle because, I'm pedaling so fast and amazing. Slow it down at least for heavier cutting or different screw threads, most likely. Those little set screws are all that lock the entire headstock to the lathe. That's it. That was the Victorian era lathe solution. So I'm back to using my super flat diamond stones on any surfaces that I deemed necessary. Any mating surfaces that were originally machined. This is just to knock down any possible damage that was done over time or wear, just in case. Like I said before, it just wasn't a heavy use machine, so the surfaces are pretty good. But to just see it take off the high spots was good enough for me to know that it was required, at least. It wouldn't make it worse. The tailstock was another part of the lathe that was slightly different between the two lathes. My older one has a wheel on it that I'm going to attach very soon that isn't solid. It's spoked, and James's is fully solid, and I don't really know why that. I guess that's easier, even though there's more material cost. It's probably more consistent to produce a solid spoked wheel, or a solid wheel than a spoked one. Not exactly sure. Might also make it a little easy since straight spokes are probably more prone to cracking. That's why we have that S-spoke design. So the nut and the handle control that back and forth play that I was showing off there, and you just kind of screw in the nut until you have a good amount of balance between resistance and movement. And that's pretty much like every other part of every lathe in existence. You want it to move, but you don't want it to be all sloppy. I believe the tools are a Morris 1 taper, and it's auto ejecting, so if I backed it in all the way, it would push in this case, the dead center out. I don't have any other tailstock tools for this, and neither did James. You can buy them now. You could still buy whatever he needs, so I'm sure he'll take it, but mine just came with a dead center that was worn out like crazy, and I'm not exactly sure what to do with it other than to restore it and just slap it right back on. And now I just adjusted that kind of back and forth play with the handle, and it's moving freely and not slopping around, so I'm happy with that. The actual writing is finally clear and be able to be read, so you can pause that and look back if you really want. I always love when they stamp things right and left. That makes my life very easy. I was actually concerned about that when I took it apart, in case it wouldn't go back, but you really only have 2 options in this case. It's not a 3 or 4 jaw chuck. You can also see the writing exactly of what it is. So it's a Westcott Little Giant improved #1 chuck. 1924, I believe, is the actual year this chuck was made, and the star, I'm not entirely sure what the star is for. So it's interesting to see that this lathe was at least used in a time years after it was actually made, which is always fantastic to see. So someone bought this chuck and slapped it on for some reason. Maybe they were never using it in the lathe. Maybe this was off of a large drill press or like a post drill at the time, and it just happened to end up on a lathe, because it's odd to have a chuck on the spindle head, especially this weird oversized one. It's going to be oiled. So these diamond stones are actually made by DMT, 3 letters. I think they are pretty good. I don't know the actual tolerances. I don't remember, but they're very flat, and they've lasted a very long time. They're my sharpening stones for hand planes and chisels and things like that, but they've really come in handy in terms of a discount surface grinder, and they are almost exactly the same size as the surfaces I need to flatten down, which is kind of nice. So it's not the most accurate way, but it's better than you just sanding it like a psychopath by hand with an orbital sander. And it's also, I'd say it's better than doing nothing. Although maybe someone wanted to bait me on that. This original surface here was never painted, and I finally removed all that was there. So it's nice to expose that raw steel face on the cross slide. In photos online, old catalog photos, it did show kind of a distinct pattern of either scraping or machining on the face of the cross slide and the face of the lathe. I'm still not entirely sure what that pattern is. You can check in the description for photos of the old catalog advertisements to see what I'm talking about. It looks like a plaid design in the actual advertisements, but it's only because that's how the drawings are drawn, and it's not actually. Although maybe plaid is the new scraping. Okay. If you're not scraping in this plaid pattern, you're not even doing it right. Now I was concerned that this was too loose. Like maybe I shouldn't have oiled aggressively on this, but once I screwed this on extremely tightly, it was fine. It may even need a washer in there, I'm not sure, but I just kind of did whatever I found when I took it apart. It was solid enough with that screw that I wasn't massively concerned, but the cutting forces will determine if I'm right or wrong. There's this little gear here. You can kind of see for a moment there's a brazed tooth, and I actually brazed this off camera, and James caught it for his lathe. I just ended up using that part accidentally because we had a box of parts and had to sort out what's what before we could send him on his way. But you could see that one tooth was brazed on, and I did file it into a general fit to the point where it just stopped making any noise when I would use it. So I'm generally happy with it, although I really wish I could have just filled it with bronze material and then just had it recut. That would have been the best way to do it, but I don't have a gear cutter or any possible setup right now to cut gears on my Bridgeport, so I'm just going to kind of have to deal with hand filing for now. Basically, I'm click spring is what I'm saying. When I talked to Chris at Click Spring, we're still working on a project. He's just so incredibly busy that I'm hoping we can get to it this year. I think it'll be really cool. I'm not going to spoil it for you guys. So the gib's going in, making things nice and solid, as we all enjoy. Here you can see the obviously broken handle. I'm assuming it had either exactly that the handle below it had, or it was just equally sized and it was two equally sized balls on that shaft. The backlash is actually amazing, which I was very surprised by on that cross slide piece there. Who knows why? Maybe another sign that it wasn't used very well. I don't know. Even the threads in here on this locking nut, or whatever you want to call it, are not very worn. And the backlash on them when engaged is not that bad either. I'm glad this was not just thrown out. I would have cried if someone threw this type of lathe out. It's technically in very good condition. The ways are a little less good condition, though. These are the bottom ways, if that's what you even want to call them. They were all painted and disgusting, so now they're freely matched up with the legs, which is fantastic. I'm assuming that's how it was originally done. Who knows? This is where you need to lift with your back in a twisting, jerking motion, just so you destroy as much of it as possible, as quickly as possible. So we taped over the ways, obviously, to protect them from not only paint, but just generally. And I'm going to be using my diamond stones again here. I have multiple grits from coarse to very, very fine for sharpening, obviously. And I'm just knocking down all these dents and all this. It's not pitting, it's just someone dropped tons of stuff on the ways here. That's not necessarily an issue as long as there's enough bearing surface to get a consistent flatness out of it, but most likely this lathe was never used for high precision machining. These were advertised technically as velocipede screw lathes, so they were for making threads on small fasteners. And even the fasteners themselves. So fasteners in general aren't, maximum precision. There's always a level of slop that is needed so that they actually turn into each other. Not to mention everything was moving really slowly, so the rigidity and the actual cutting forces were light. Everything about it is kind of that light duty, if you want to call it. So finally, cross slide is on. We're going to position it right into the carriage direction lever, if you want to call it that. You can hear the clicking of the ball detent thing engaging and disengaging as you position that around. And once it's together, you can hear that there isn't that much noise with the gear that I brazed, which I'm really happy about. And the tailstock fits on beautifully and slides very easily, which makes me happy. I would have loved to, slap this on like a massive surface grinder and had all that nice way ground, but that's way too expensive and kind of just not necessary. I don't really know what I'm personally doing with this lathe in terms of after it's being restored. I won't use this. Like straight up, I will not be using this on a daily basis, and I probably would only use it to show people kind of what a pedal metal lathe functions like and looks like. But I would love to pass it along to somebody. I'm just concerned about the shipping costs to the US might be, a couple of $100, and then the lathe itself. I don't know. Maybe one of you, or maybe you know somebody that might want this, because I'll definitely sell this. I have no need to keep it in my collection. I just love that it exists as a product to be purchased. It's just so foreign. You'd never see this today. So those are those hanger brackets that were cast. They hold the entire pedal system in place, and we only had one set of pedals. We had to completely fabricate the other set, bending 7/8 inch rod. We bent it exactly like that, and we made kind of triangular foot pedals with collets attached to the sides. It was all a process, and you can see that on James' video if you want to head on over to his channel to check that out. There's a lot more manufacturing kind of going on his video than on mine here. The pedals literally just hang. They just hang in place. It's not the most secure. Like, all of your weight is on 3/8 of cast iron ring. It's horrendous. I could see someone, like stepping on the cast pedal or the pedals hard enough to break that cast iron hanger easily. So maybe that's why we had to get new ones made, because they were destroyed previously by somebody. Definitely not the best design. for those. I'm not exactly sure what they were thinking there. Here's the big flywheel, all painted and central. You can see the threaded portion that someone welded on for some reason. I want to say it's a PTO so that you could slap on and power something else at the same time. But it just hurts my brain so much to even think about. Like, what else do you need to pedal power? Is it really... You had nothing else around that could do anything, that could pedal? It's just weird. I would have loved to see what that was attached to. Like, was it a food chopper? Was it a paint sprayer? Like, what was it? Here's parts that did not exist at all when we took this apart. This is the seat bracket. It actually goes on the other side of where you actually sit. This cast piece was also cast brand new, probably because the chairs are easily broken. You can see how ornate the actual seat is. It looks very much like a farm tractor implement type, antique type seat. I can't believe they would just cast the seat and that's it. It's just cast iron, so fragile. I busted out my previous restoration on the belt lacer, even though it doesn't fit. The type of belt lacing that I got doesn't fit in this machine. It still does the clamping action, which is really all I need. These are technically hammer-on belt lacing, but come on, you have the machine, and it's way more fun. The leather belting and the clip were purchased from McMaster Car. You can get different thicknesses, different widths, different belting material. This is just straight leather with fabric reinforcing, so there isn't a lot of stretch, which does happen with leather easily, especially over time. And that does provide a little bit of grip, extra grip as well. You can just get straight leather if you want also. I ended up putting a little bit of belt dressing, which is basically like sprayable rubbery stuff that helps grip the leather to the actual pulleys, since the pulleys are completely smooth surfaces, and what can you do? Here's the blasphemous nickel-plated brass, whereas brass would have been much nicer in my opinion, but at the time, nickel plating was the rage. At first I thought this would be solid aluminum because I'm insane, and it definitely wouldn't be. Aluminum was incredibly expensive at this point in time, so it is not aluminum. Still don't know what that's for. It is blocking me from actually tying the flywheel down so it doesn't fly off. I also found the collets that go in the pedal carriers. And just look at the teeth in the bottom left of that gear. It's just ridiculous. So I don't know if this was made by somebody or not, but it's not the best gear. So it's not as quiet as I'd hope it would be either. This is the fancy attempt at using a drill chuck. It's not able to center anything. I tried back and forth a few times before I actually went to do the cutting to center it better, but it's angry. You gotta bust out the steel toe Crocs for safety purposes. You never know. It's also you have to pedal backwards, which drives me nuts. I don't understand the point of that. Like, just to make it a little more difficult for you to cut something. The belt's performing fantastic. Yeah, you can see all the gears gearing away. And you can take some time and spin the headstock a bit to engage the back gears. And now everything's moving like crazy. And we can actually start to try to cut stuff. Here I'm taking like the lightest possible cut that any human has taken on brass, just because it's so ridiculously uneven. And if I even push it a little bit, the whole lathe just comes to a start because my legs just can't keep up with the amount of power required to cut, you know, anything more than just this little amount of chips. You can kind of see me here going for it, but like you get tired very quickly the second you start cutting. It wasn't the worst finish in the world, but it's got to be at least second place worst finish of all time. I couldn't demonstrate this, obviously, because I'm supposed to lock it back down, but it was just a demonstration to show you the movement. The power feed's working just fine. Very happy with that as well. And you can kind of see how fast you can actually go. I just push it to the limit. I kind of wanted to push get a tachometer on there and see how many RPMs I was actually getting. But maybe that's for Instagram. I'll show that off. That's pretty much it. It's definitely a workout. It's not easy for an extended period of time. It just seems very odd that it exists in the first place, but it is gorgeous in my opinion. And once again, I thank you all for listening and watching, and I will see you in the next one. Later.